Studying our fascinating chemistry, we're looking at bonding, chemical bonding. Bum, 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 bum. I know that's really bad chemistry. Okay, bonding is a process of combining two or more elements chemically. Now there's two different types. Look at the first type today, which is ionic bonding. Definition of ionic bonding. Definition of ionic bonding is bonding due to charge caused by electron transfer, resulting from ionization energy, electron affinity member. Ionization energy need to lose an electron, electron affinity energy need to gain an electron. Since metals prefer to lose and non-metals prefer to gain, ionic bonding is a metal to non-metal bonding. Now, in order to do this, we have to have what is called ions, all right? Ions are charged particles, it's either positively charged or negatively charged. Cations are called a positive, anions are called a negative. And if you have a hard time remembering, just remember there's a little plus there in the cation from there. All right, so let's take an example of like sodium chloride. We know that's an ionic bond. So let's take sodium, which has 11 protons. In order to be neutral, it also has 11 electrons. There's 2 in the first shell, 8 in the second shell, and 1 in the outer shell. Chlorine has 17 protons and 17 electrons. Now, that one in the outer shell there of sodium is more stable if we get rid of it. So that's what I'm going to do. I'm going to kick that electron off. When I lose it, because we now have 11 positives and 10 negatives, we have a positive charge. Where's it going to go? It's going to go over to my chlorine, and now I have 17 positives and 18 negatives, and the charge becomes negative. Now, the best way to represent this is called Lewis dot diagrams. It's meaning determining ionic bonding. So, how do we do this? We take our element Na and Cl. How many valence electrons does sodium have? Sodium valence electrons has 1. So, put the sodium right there. How many does chlorine have? Chlorine has 7, so we put them around. 1, 2, 3, and let's put the rest, 4, 5, 6, 7. Now we have to ask ourselves, is it easier to lose 1 for sodium or gain 7? Well, obviously it's easier to lose 1, so I put my sodium without a dot because I lost it. But when I lose it, I have to show that it's lost. And so in Lewis dot diagrams, I put parentheses around it and make it charged since it's now positive in charge. Chlorine, is it easier to lose 7 or gain 1? Well, it's obviously easier to gain 1. To put my chlorine with the 8 electrons, more stable, brackets around it, and negative. They're now opposite in charge, equal magnitude. We get NaCl. All right, so we'll do this one in class, this one in class, this one in class. All right, the other way we can also do this one called oxidation numbers. These are numbers associated with elements for ionic bonding. In order to look at the periodic chart. Okay, remember we have our periodic chart. We have valence electron numbers. 1, 2, 3, 4, 5, 6, 7, 8. We won't remember the transitionals or the rare earths. All right, so let's only look at the alkali, nitrogen group, oxygen group, and the halogens. All right, if I have 1 valence electrons, is it easier to lose 1 or gain 7? It's easy to lose 1. So all that have an oxidation number of +1. If I have 2, then oxidation number is +2. Now 5, I'm not going to lose 5. I much prefer to gain 3. So the charge becomes negative for 3, but it only goes down to arsenic. Okay, oxygen, I have 6. It's easy to lose 6 or gain 2. Gain 2. Oxidation number is -2, and that's through tellurium. And then the halogens, I have 7. Is it easy to lose 7 or gain 1? Easy to lose 1, gain 1, and I get negative, and that's all the way down. Now, there are 3 additional ones, but they're easy to find because they make little stepping stones. Silver's oxidation number is always +1. Zinc is +2. Aluminum is +3. So let's look at doing aluminum oxygen. From our oxidation numbers, we said that oxidation number of aluminum is +3. Oxidation number of oxygen is -2. Now, that does not equal out, so we have to get them to work out. There's 2 ways of doing this. Either find the common multiple, 3 and 2, that would be +6 and -6. What do we multiply +3 to get +6? 2. What do we multiply -2 by to get -6? 3. Or the easy way to do this, see this little 3 here? It's right over there. See this little 2 here? It's right over there. Okay, we'll do these in class. That's it. Take care. Any questions, let me know.